Okay, so today we're going to continue talking about costs. Last time we talked about fixed costs and variable costs, how they interact, how the average cost curves interact, and we introduced the idea of marginal costs. Today we're going to introduce time into the equation. We have this idea of the short run and the long run. We're going to analyze how the time horizon affects the cost structure facing a firm. Uh, the most important point to note here, and the most important point um, distinguishing the short run and the long run, is that in the short run, the amount of capital is assumed to be fixed. So you can change the amount of labor that you're using, but you cannot choose the amount of capital. A firm's short run total cost curve describes the total cost of producing various quantities of output when the amount of capital available is fixed. Just like I said, in the short run, you can change labor, but you cannot change capital. We're going to look at a couple of graphs to see this in action. Imagine that you're a car company and you're producing a bunch of engines. Uh, the left-hand graph there is the relationship between labor and capital, and on the right-hand side, it's the amount produced and the cost to your firm. So if we assume that costs are $100, in this example, the firm can produce at most 10 engines. We're going to keep doing that, creating a new point on the right-hand graph. We're going to add another line if we assume that costs are $180, then we can produce at most 20 engines. Add that point to the right-hand side again. And one last one, if costs are $300, then we can produce at most 30 engines. Now we're going to connect them all to create this long run expansion path. This is just the idea that in the long run, this is the most efficient way to allocate our capital and labor. The thing that's changing here is, or the thing that's noteworthy here is that both labor and capital are changing in that left-hand graph, which is how we know that we're operating in the long run. The next complication is, let's say that we fix the level of capital because we're operating in the short run. So let's say we fix the level of capital at 6 units. At 6 units, we can produce exactly at that Y point. We could also produce, if we assumed costs were 120, we could operate on that Q equals 10 curve. We add it onto the right-hand side, or we can move up, say costs equal 360. We're at that fixed level of capital, and now we're at that Z prime. The problem with these two, Z prime and X prime, is that even though the cost curve is the same for that X prime, it costs 120 to produce 10 units, and at Z prime it costs 360 to produce 30 units. That's not the efficient allocation of our resources. We can still produce 10 units at point X, and we can still produce 30 units at point Z in the long run. So in the short run, since we have this fixed capital, we are not operating at the long run efficient outcome. To sort of better illustrate this, we're looking now at the long run average total cost curve and how it relates to the short run average cost curves. Remember, average cost curves are always just the cost curve, whether we're talking about fixed costs or variable costs or total costs, divided by the amount that is being produced, right? You're just dividing whatever that number is by Q. So here we have our average total cost curve in the short run when we're using the same example as before. We're just dividing the total cost by the quantity. We're going to do this for our X, our Y, and our Z. So again, at point X, we're producing 10 units. At point Y, we're producing 20 units. And at point Z, we're producing 30 units. You'll also notice that we've included X prime and Z prime here. These are higher on the total cost curves than their equivalents X and Z. That's because it's not the most efficient use of capital and labor. So in the long run, just like we saw in the previous graph, we had that long run expansion path. The long run average total cost curve is just going to be this lower envelope right here of all of our short run average cost curves. So it intersects through point X, point Y, and point Z. Important to note, again, we have our short run average total cost curves for different units, for different quantities produced, and the long run average cost curve is the line that sort of follows underneath or is the lower envelope of all of those curves together. This just reinforces the point that we made in the previous slide, that the long run average cost curve is the most efficient combination of capital and labor. We also have to think about marginal costs. Just like last time, a lot of economic thinking depends on the marginal costs of things. Remember, marginal cost is the cost of producing one additional unit of something. Just as with average cost, short-run marginal cost is the cost of producing an additional unit of output when capital is fixed. The long-run marginal cost is the cost of producing an additional unit of output when both capital and labor are fixed. So we're operating in the same assumptions. We're saying that in the short run, you can change your labor, but you can't change your capital. And in the long run, you can change both, right? All of the assumptions about time are the same. We're just shifting from how we were thinking about things before, the average costs. We're now talking about the marginal costs. The important thing to note in this graph is that we have our short run average cost curves here, just like we did last time. We have 1, 2, 3. Those are our 3 average total cost curves in the short run. Now we're introducing the marginal cost curves. We have the marginal costs in the short run here for 10 units, for 20 units, and for 30 units. And then we also have this long run marginal cost curve. You'll notice, similar to the previous lecture, the short run marginal cost curves always go through the minimum point of the average total cost curve, right? Think about the GPA example in the previous lecture. If you have a 3.0 GPA and you get a you get a B minus in a class, sorry, if you get a C in a class, so your long run GPA is 3.0, but you get a 2.0 in a class, that 2.0 is going to pull the 3.0 down a little bit. That's what's happening with these short run marginal cost curves. It's decreasing up until that minimum point, and then as the marginal cost starts increasing above that minimum point, the average costs go with it. However, since in the long run we operate at the lower envelope of average cost curves, this marginal long run marginal cost curve will be flatter than the short run marginal cost curves. You can see that here the slope of this line is less steep than the slopes of these lines. Also, you'll notice that if you remember in the previous slide, the uh, the long run average total cost curve passes through this point Y. Well, our marginal cost curve also passes through that point. If you imagine that the lower envelope is here again, the long run average total cost curve, it'll look something like this. It'll pass through this point, and then it'll start rising again. The idea is the same. As long as the long run marginal cost curve is below the long run average total cost curve, the long run average total cost will decrease. Then at the intersection of the long run marginal cost and the average cost, that's your minimum long run average cost curve. Then as the marginal costs start increasing again, the long run average costs start increasing again. Okay. The important point to remember is that the uh, the marginal cost curve pulls up or pulls down the average cost curves. It's the same in the long run as in the short run.